Now let us learn the topic electric power. Recall that in Standard 9, chapter number 11, Work and Energy, we have learned about power. There we learned that the rate of doing work is called power. Okay, it is also the rate of consumption of energy. That means how much energy is consumed per unit time. That is also power. So now you have to remember these two definitions, the rate of doing work and the rate of consumption of energy. This both are called as power. Now, equation 12.21, which is the equation of Joule's law of heating. What it is, H is equal to I square RT. So this equation I square RT gives the rate at which electric energy is dissipated or consumed in an electric circuit. This is also termed as electric power. So now we have power P is equal to VI. Or else another equation, P is equal to I square R, that is equal to V square divided by R. Now how did we get this equation? You can see it is displayed on the screen in the textbook. I have mentioned with pencil. You will also write so that you remember how this equation has come. We know from Ohm's law V is equal to IR, right? And here we have equation P is equal to VI. V is equal to IR. So this V value we will keep in equation P is equal to VI. So then the equation becomes P is equal to IR in bracket and one more R, I. Okay, so we can, two I's are there. That means we can write P is equal to I square R. Okay, now we got P is equal to I square R. See, it is written in the textbook P is equal to I square R. This much we got. Now, from the Ohm's law, we know the value of I. We can write it as V divided by R. Am I correct? Ohm's law is V is equal to IR. So I can be written as V divided by R. So that value of I we will keep in I square R. Okay, now I is V divided by R. So what will be I square? It will be V square divided by R square, right? So V square divided by R square we will keep in the equation P is equal to I square R. So equation will become P is equal to V square divided by R square multiplied with R. Now in denominator R square is there, numerator R is there. So one R will get cancelled. So we are left with V square divided by R. This all derivation of equation I have mentioned in the textbook with a pencil. So you will also write. Okay, so this way we got P is equal to I square R. Also we can write it as P is equal to V square divided by R. This all equations you remember, whichever numericals value we will have, from that we will use the formula. The SI unit of electric power is watt. The symbol is W. It is the power consumed by a device that carries 1 ampere of current when operated at a potential difference of 1 volt. Now again it is there. If we want to define 1 watt, then how can we define? What is the formula? P is equal to VI. Now unit of power is watt. Unit of potential difference is volt. Unit of current is ampere. So how to define 1 watt? It can be defined as when it is the power consumed by a device that carries 1 ampere of current when it is operated to 1 volt potential difference. So we can write it as 1 watt is equal to 1 volt into 1 ampere, that gives 1 volt into ampere. The unit watt is very small. Therefore, in actual practice, we use much larger unit called kilowatt. This also we studied in standard 9. Watt is very small, so we have to use kilowatt. It is equal to 1000 watts. Remember, whenever kilowatt is used, that means we have to use 1000. Since the electrical energy is the product of power and time, the unit of electric energy is therefore watt hour. Because why it is? Because electrical energy is the product of power and time. That is why. Now, 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour. The commercial unit of electrical energy is kilowatt hour, commonly known as unit. 1 unit is equal to 1 kilowatt hour. Do you remember? We have learned this in standard 9, right? 1 unit is equal to 1 kilowatt hour. And 1 kilowatt hour is equal to 1000 watt multiplied with 3600 seconds. Why? We have converted hour into seconds. So that gives us 3.6 into 10 raised to 6 watt second. That gives us 3.6 into 10 raised to 6 joule. Okay, so 1 unit is equal to 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule. If it is asked to you, 1 kilowatt hour is equal to blank joule. This you have given answer in standard 9, right? 3.6 into 10 raised to 6 joule. Remember. So this is all about electric power and the units, the formulas, and about 1 unit or else 1 kilowatt hour.